Welcome to the AWS Developers Podcast. Today in this episode, we're talking about serverless ETL, extract, transform, and load. Good morning. Thank you for downloading the Developer Podcast. Every Friday morning, we're available in all good podcast applications, Apple, Amazon Music, Deezer, Spotify, YouTube, you name it. If it is a good podcast application, I'm sure you will find the Developer Podcast there. There might be a bit of background noise behind us because we're recording this episode live from the AWS Summit in Bangalore in India, where I travel with Tiffany. Tiffany, thank you for being there.
Hi, everyone.
Last week in London, this week in Bangalore. And our guest today is Poonam. Poonam Pratik, thank you for being here. You're part of the AWS community builder. You have a talk today or tomorrow at the summit. You're going to talk about serverless ETL. So maybe let's start. First, thank you for being here. Really appreciate it.
Thank you so much, Sebastian and Tiffany, for inviting me here on the podcast. This is my first experience and I'm very, very happy to be here.
We are going to explain why serverless and why ETL in serverless and how you did it. But maybe let's start with the business challenge. What is the starting point? Why you try to clean your data in a serverless way?
Okay, so rather than thinking about the problem, let's start with what a business is required. So business really wanted to grow, and if they want to grow, then if they have to take a right decision. To take a right decision, they need a right amount of data and correct data on hand, and then only they can take a right decision. But think about the scenario where the data is chaotic, where the data is messed, where data is incorrect. In that case, they won't be able to take any right decision. Now, other way around, about the manual process. Someone will be sitting there and check all this data. Now, out of millions data, do you think it is possible?
It's opening an Excel file and looking at data and changing data manually. Of course,
just think about that way, that someone is opening file and going through all those CSV one by one and comma separated file. Do you think it is possible? And human can also make a mistakes. But in a machines, it's almost zero, or I would say if in case the coding is wrong, then only it is chance to have an error. Otherwise, it's completely okay. So to overcome the challenges of the businesses where they want to go through the millions of the data, hundreds of GBs of the data to make a right decision, to clean the data so that the data can be useful for the reporting purpose, data can be useful for the analysis purpose. And nowadays, it's AI ML everywhere. You know, the best use of AI is just analyze and summarize the data. And whatever you have in your bucket, just go and provide a prompt and it will give you the right amount of
answer if the data they used to be trained are correct. Because the usage is to say if you put garbage in, you will get garbage
If
out.
the data is correct, then only you will get the correct information.
So how customers are typically cleaning their data? Because you do it serverless. If you do it serverless, it means there is another way.
Yeah, so basically, let's divide this in two ways. It's serverless and ETL. So ETL is like you already have mentioned, it's an extract, transform and load your data in such a way so that you can run a hierarchy to clean the data and to the partition data. But how about having those solution in a serverless where AWS will provide all the services and AWS itself manage the resources? You don't even have to think about anything on how the architecture on the behind the side is going to run which EC2 at what time and what kind of resources they are going to allow.
Yeah,
that's the beauty.
That's a lot of planning. If you do it with virtual machines, you need to plan for the size of your virtual machine, the quantity. In the good old days, when I started at AWS, we used something called EMR, Elastic MapReduce, with Hadoop.
Yeah,
you've been through that too.
Yeah, you also have to think about the which library I haven't installed on my Docker.
Yes, also all your dependencies that you have to manage.
Exactly.
So you choose a radically different approach, which is to use the serverless service, so step function and Lambda basically, and to make it short. But
yeah, so just think about that your data is flowing in the pipeline and the pipeline itself cleaning your data, and at the end of the pipeline, you are getting all those things ready to use. So data is keep flowing, and while it's flowing in pipeline itself, we have a solution to clean, we have a solution to make it ready. So that's all the idea behind this serverless ETL architecture.
So what's the high-level architecture? If we look from an helicopter view, what are the main AWS service and how does your pipeline look like?
Yeah, so just think about that we are getting the data from different branches or different offices into one common bucket or say one common folder, and that's our S3. Now you don't even have to think about the size of the S3 because it's serverless and it expands whether you are dropping 10 GB of file or whether you are dropping 100 GB of file. So it will expand. So
the only limit on S3 is your credit card.
Yeah,
How much
it's only on the credit card. Yeah, of course. And on the limit on your how you are spending because it's what you are earning.
So the data arrive from different branches, offices into one S3 bucket.
Into one S3 bucket.
And what's happening?
And then once the data we receive, S3 will itself notify. So because it's event driven and everything is orchestrated in a step-by-step function, when we receive data into a common bucket, it will notify our step function and will say, hey, hello, I have received the file which you are looking for. Now what? And he will say, okay, don't worry. Everything here and everything is orchestrated from me. Now I will validate the data. Whatever you are sending is will pass through all this validation we have defined in a Lambda function. So basically, it will actually invoke a Lambda function, and Lambda function will validate those data we have received in our file, which is a CSV file at the moment. If the data is not valid, we will move those particular file to another S3 bucket.
Okay, so you're using AWS step function as an orchestrator.
Yes.
This is where the workflow is defined, and each step of the workflow invokes a specific Lambda function that have a dedicated task, like verifying the quality or the validation of the data?
Yes, so the orchestration in such a way, so it already have step-by-step process, and each and every process depends on their previous output. If the previous output is fail, then they already know what to do, and if it is passed, they know what to do. So if it is fail, we will move that particular file to another bucket. So we know that file is processed, but it is not useful at the moment. So we are moving to another error bucket where all the files which has error will be stored. And then we will think about what will happen to those error files.
It's a UN that is look at that. Or
maybe human, or we have to we also have defined another process which will go and find out more in a deeply that this kind of error file is there. What to do? Definitely, we will notify our client that we have received this kind of data at the moment, and now it is the solution we have designed is not able to process, so we are moving it to the different bucket.
So when you say that the different data come from different sources, does it mean that they have different formats, that nothing is standardized? Or
yeah, it can be unstructured data, it can be structured data, or it can be some kind of junk, or it can be a PDF as well. But at the moment, we are only focusing on the CSV file.
And the size of these files might be quite large, I guess. So how do you pass them to the Lambda function? Do you pass the entire file, or is there a way to stream the data from S3 to Lambda?
We are passing entire file to the Lambda function, and the Lambda will break down the data and will process one by one.
Mm-hmm. This means also you need to unpack a lot of libraries and code inside your Lambda function, like Panda, I guess.
Yes, Panda. We are using Panda because Panda is the base for the CSV kind of structure.
So what is the benefit to use a step function as the orchestrator?
So the step function is orchestrated perfectly. So you know that the next step, what can be next step?
Yeah, it manages the state of the pipeline, actually moving from one step to the other, even retrying, if I'm correct.
Yes, even though the step function is fail, at the moment we haven't considered that kind of scenario, that if but if when it fails, it is moving to the another bucket. And we are only considering those files which pass those validation.
Mm-hmm. Do you have an idea how many Lambda functions you have? How many steps in the treatment in the pipeline roughly?
Yeah, we only have 2 Lambda functions and 2 steps.
Okay. So one is then is the validation, and then there is a transformation.
Yeah, no, the transformation is itself written in the glue.
Okay, we're going to come to that part. So validation and
Just the validation and how to invoke the when to invoke that particular step functions.
okay.
So there will be a lambda in between somewhere. So basically, just think about the scenario. You are getting a file into S3, and now S3 notification event will call lambda function, and now lambda function will invoke step functions, and step function will pass those data to to another lambda, and that lambda is quite big, and will apply the libraries of Panda
To validate the
to validate the data, and will decide whether this data can be go further or not.
Okay. So what's the next step? Imagine the data at
Yes.
8.
So now imagine that data is correct. So we will move those particular data to another S3 bucket, and we'll say that clean S3 bucket, or the data which has a, just let's name it a row cleaned bucket. So we will be moving those particular file to another S3 bucket, where a crawler can go and get the information.
So what is the crawler?
This is a part of whole glue job. Now we already have defined when the crawler will schedule. So crawler will go every hour and will check on that particular S3 bucket whether we have received the data or not. When we have received the CSV file, the crawler will understand the type of the data and will generate a schema into AWS data glue catalog. So now the catalog know that whatever CSV data we have received has these types of columns, and the format of the column is a date, the format of the column is a number, whether it's a string, etc., and will make a schema ready for the next process. And in next process, glue will get the data from data catalog, the schema from the data catalog, and read data from the S3 bucket itself, and will partition the data. First of all, it will compress the data into the Parquet format, because CSV is not the format for the millions of the data. When the data is really in the number of high number of the data are there, we want to have a columnar structure data which is fast in a process as well. So performance wise, obviously Parquet, Avro are really fast in the processing. So we are storing those raw data into the Parquet columnar data, and will again move that file and to another S3 bucket, which will only have Parquet related data.
Okay. And
So now the glue job.
I interrupt you
Yeah,
about
sure.
the partitioning. So what is partitioning? It's to split
So at
data
the
by
moment- yeah, at the-
timestamp?
Yeah, so at the moment what we have done, we only have compressed the data and have shifted to another.
Okay.
And glue also, once it is moved to the Parquet format, now glue know that the data is ready for the further partitioning process. And then the beauty of the glue, you just drag and drop, and behind this it will write a script for you.
Script for you. Yeah.
So you can go and check the script. It's like a no-code idea. And I really like this no-code and low-code paradigm, because you don't even have to nowadays type anything. Thanks to Amazon Q, it's going to write everything for you on the prompt. And again, the glue will generate a script, whatever you want. So just by dragging and dropping, the glue will generate a script for you.
It's a Spark script, if I remember.
It's a PySpark, and it's like a netbook. Have you used the Jupyter Netbook?
Yes.
It's very similar to that one. You can have everything on, and the beauty is like you can run a part of that particular script as well, if in case you want to check it yourself. But what we do?
When you prepare that pipeline, you go to the Glue console, where you can see a sample of your files and the data structure. You can drag and drop the fields from the source to the destination.
Yes.
And Glue generates the PySpark
script behind the
and
scene.
you'll execute it when a new file arrives.
Yes, and it will execute on the way you have designed. So if in case you want it to be run on demand, or you want to run it every hour or every minute, whatever every month, you can set up on the crawler side, and the glue job will run everything for you. So once the data is partitioned, and then we will move it to the another S3 bucket.
At this point, do you treat the different like the data from the different sources differently, or do they all collapse into the same file?
Into the same S3 bucket. So from the raw S3 bucket, we have decided to validate the data and move it to the another S3 bucket. Once we have a cleaned raw and validated data into another third S3 bucket, we will compress it and will move to another S3 bucket. We will have this Parquet based compressed files.
Yeah, but I guess when you said like the data come from different sources, so different offices, does it mean that you need to flag each different sources to make sure that all of the data are treated separately? Or
no, all of the data will be treated at the same. So the solution can it's common solution which can apply for the order related data, or can be transaction related data, or can be sales related data too. But only the different thing is like you have to match the schema.
Yeah,
Yes.
and that's the part that Glue handles as well.
Yes.
So the last step of Glue is to do the partitioning.
Yeah. So the partitioning is like how you want to. It's a very complex decision how you want to decide, because once a partition is done and you are storing into the S3 bucket, you also should be able to query using the Athena.
Mm-hmm.
And if in case you want to use another services, or you want to give it to the Bedrock for the further processes, then you also can do it. So at that time, we will partition data and will move it to that S3 bucket, and that S3 bucket will be available to Athena for any queries, and also can. So now just think about the CSV file we have. What to do with that? Now that file will move to another S3 bucket for the archiving purpose. So now we have read the data, stored into the different format. Now it's ready for the query. But the source file, which can give us the history, will be stored into another archive folder. So we know that the decision we are making is through this particular file.
I've heard you said at the end there might be Bedrock. So does it mean that some of your data goes through AI neural processing?
Yeah, at the moment, the solution is not providing any kind of collaboration or integration with Bedrock. But yes, when I was trying the different things using the Nova, I have used those kind of data just to understand that how I can make a decision and how it can help.
Yeah, you're opening the door to future possibilities. Now that you have the data clean and correctly compressed, partition, you have multiple usage.
But it's completely for my trial purpose, not for the client.
You mentioned Athena, which is probably the current way to exploit these data, to use these data, but you can plug different systems as well. QuickSight is another one. Bedrock for the future might be another one as well. I think when we prepared this episode, you talk about SNS notification as well. So you're notifying the consumer of the data that they are available?
Yes. So basically, we want to inform clients straight away that whatever file you have provided, we don't want any kind of like a 1 day or 2 day gap in between. So we notify our client on their email address as well as our developers and the team, like list of the email, whatever they have provided, this particular team should be notified. So we notify on SMS as well as on the email address.
And you give them what? A link to the S3 bucket or something like that?
No, we give all this information that where this data has fallen and what is the reason behind this, because we are also storing the log into CloudWatch.
Okay.
So we also provide that particular CloudWatch things into the email that now you can go through here, or this is the link you can traverse to particular things for the further debugging.
So you said you keep the original file as an archive, and then there is, of course, the transform file as well. And do you keep also all the intermediate steps, or do you eventually delete them for?
No, we actually decided to keep the files as it is and move to the another solution. Like you can store it into the Glacier whenever you want. So we have a 3-month plan that to move it to the lesser
storage tier that costs less but takes a bit more time to retrieve. But that's the way you manage cost, because how many copies are you ever of
Exactly. We can have lots of data and we just can't keep it if in case we are not going to use it frequently. So it's always better to store it in a deep archive.
Any challenge or lesson you learn while developing this solution? Something that was looked like easy at the beginning, and then when you're coding it, you realize that maybe there's a bit of difficulties there.
You know, like what the expectation of the business. They want to save on the save on the cost.
Mm-hmm.
Whatever architecture must be the cost effective. The architecture has to be very scalable, and architecture must notify them for each and every error step or each and every success step. That was the challenge. But on top of that, the thing is the partitioning. How you want to partition your data in such a way so that if in case, for example, you want to find out the solution from the April to 2025 month, your Athena shouldn't go to each and every query. Yeah, if in case they going to, if Athena is passing all this data, it's going to cost you a lot. But if it is partitioned properly, then Athena know that I have to go to the folder which is 2025, and now it's April, and now the particular third of the April, and go get the data from that folder. But along with that, the solution is also should be available on the order side. So if in case you want to partition your data onto client ID, will be different, and if in case you want to partition your data onto like day, month, and year wise, then also the behind the scene, the script will be different.
So it means you create multiple partition version of your data file depending on the queries. If the customer are query by customer ID, you need to partition by customer ID.
Yes.
Date. So it's multiple files, multiple transformation for each incoming file.
Yes, as I said before, that the data can be useful for the transaction purpose, and the solution can also be useful for the not just analytics on the day side, but analytics on your customer side as well. If in case they wanted to understand the customer flow and order things, then they also wanted to partition it on the order ID.
It means that if the business comes with a different ID saying, hey, no, I want to have that use case, I have a new way to query the data, you might need to adapt the last step of the flow to generate another partition version of your data.
Yes.
Mm-hmm.
What are the different use cases used for your ETL pipeline?
One use case can be when you have a loss of transaction or bank-related transaction. You can also use for that. If in case you have property-related deeds and you want to understand how many properties in this particular area are there, and which year which property is registered or built, and when it is been transferred. So all this data can be partitioned. So the property related data, the bank related data, then transaction related data, and this solution can also be useful in the medical field, where you want to understand in which particular day how many patients were there. And
one of the challenge many serverless developers are sharing with me is observability. When something goes wrong, how do you debug that pipeline?
So for observability and monitoring purpose, we have used CloudWatch. So each and every time it is going to log the data into the CloudWatch, but with a particular tag. So you know that these by defining the tag onto S3, by defining the tag into the Lambda, by defining the tag into Glue, you can segregate those particular log and data. So obviously, monitoring each and every step is very important. At the same time, also logging this data is important.
And did you develop dashboards or tools to get some visibility about the state of the pipeline?
So basically, those things are developed in the no-code data. So whatever things we are getting, we are also transferring to a different database using API connector. And so API gateway will send those data to a different it's a different application.
Okay.
So those data, once it's ready, we are sending it to different application. They store those things on a application and at least get the status of pass or fail.
Now that the solution is there, it's live, it's in production, did you achieve the business outcome that were expected at the beginning? I mean, is the current solution giving you the business objective you talk about, cost reduction, scalability? Are you happy with the solution?
Yeah, of course, I'm happy with the solution. But, once it's designed, you always feel that, some kind of improvements we still can have on our
Of course.
on
It's a
the
never
site.
story.
Yeah, but it's live now, and whatever glitches is there, escape it as it is.
If you have to give advice to the people that are listening to us, to our listeners that want to start an equivalent serverless ETL projects, what are the things they have to pay attention to?
Okay, so the one advice I would like to give to the listener is that the serverless is a future, according to me. And thanks to AI and ML, people don't want to bother about the resources they are assigning behind the scene. How your business only want a result. They don't care behind the scene which function is running, behind the scene what you are doing, behind the scene where you are storing. They just think about the security, and they think about cost-effective solution which is scalable and never stop. And must should have this observability and monitoring functionality in it. So if something is happen, it should be able to restart. So if in case something goes wrong, you have to restart the EC2 server. That kind of thing is not there into serverless side.
Yeah, you have less operational burden.
Yeah, if in case they need some of 2 CPU, they will attach 2 CPU, and suddenly they realize, okay, the data is in GBs, then let me attach more CPUs to process the data.
So we touched a bit about the future already, because you mentioned Bedrock. But now that the solution is in production, what are your axes of improvement? What are the things you're willing to change or to improve?
Okay, so we already have think about this when we were building the solution, that in the future what we want, that the born of AI ML is only because of the data. You want to get a perfect decision from whatever information you are storing for your enterprise, and for that you want a kind of train foundational model. You don't want to train your machine, because if you are going to train your machine, it's going to cost a lot. In that case, you can use a ready foundational models from Bedrock and can provide that particular data and make a decision. And that decision can be just by prompt. Say, hello, in 2022, how many customer has withdraw the data from ATM machine, and which ATM location was highly used. So that type of data you can integrate and can get information straight away.
Yeah, we can talk to all this.
Yeah, you use it to get insights from the data.
Yeah, and thanks to MCP now, that you also can include third party, that, what was the weather at that time? Do you remember? So BBC Weather will give you the information on this particular day. The weather was very rainy and flooded, so no one went outside to withdraw the cash.
If cross-correlation of different data stream from different providers.
Yeah, is that a tool that you give to your customers so they'll be able to check with their data, or is it more something for you to have insight?
No, this is what my own insight, because when you are providing some solution, you always have a back of a mind that when it can fail. So we know that this is the information useful for making a decision on the business side, and as another opportunity on the development, yes, this can be a next application to develop.
Poonam Pratik Patel, thank you very much for being on the podcast studio at the AWS Summit in Bangalore today. That's why you might have heard a bit of background noise. You have a talk later today on the same subject, so good luck for your talk.
Thank you so much.
And thank you for having listened to this episode until the end. Thank you, Tiffany, also for your fresh hair questions to Poonam. See you next week in all good podcast application. But now, go beat.